So this is the BrainFPV Radix Li wing kit that comes with the wing power board. Now this kit is made especially for flying wings or standard airplanes. So if you're thinking about using it for a quadcopter, you would have to buy a different BrainFPV Radix kit. The reason is, as shown here, the wing power module only has one connection for one ESC and cannot support multiple motors that would be needed for a multi-rotor. Okay, here's the pinout for the Radix Li wing kit. And basically we have the FC here with the top and bottom, and then we have the wing power board up here, and then there's a little picture of them connected together with the ribbon cable right here. Okay, let's start up here. We've got the video out going to the video transmitter right here. Then there's a UART one which can go to your transmitter as well, but I'm not using that. Now we have the camera control, not using that either, but you might. So the main pins are the video out, video in, which is coming from the camera, 5 volts for cameras that don't draw too much current, like ones that have batteries, and then you have ground for the camera. All right, moving along, let's go to the outputs. Now remember, these go through the ribbon cable from the flight controller to the power board up here. So pin 1 right here goes to this pin right here, pin 1 on the power board, and that's for your ESC right here. And you can see there's only going to be one motor. If you're going to have a twin engine, you'd have to connect both throttles to pin 1. Now if you want to use the jumper right here to apply 5 volts to the servo rail, then you won't connect this red wire. You'll have to disconnect that. No wire from the BEC on the ESC. All right, now the next pins, we have 2, 3, 4, 5, and 6, which are all going to be servos. So usually pins 2 and 3 here are for your ailerons, and then you have elevator. On 4 and 5 is the rudder, and 6 is left over for whatever you want to use it for. Now this can be configured in the mixer tab as well to maybe change what the function of these pins are. Okay, and finally we have the receiver down here, and this connects on right here on the side of the board. And I'm using a PPM receiver, which is an EZUHF long-range setup. So I'm using PPM, but this will take a lot of other different receivers as well, and that's in the manual. There's also a UART 6 port down here where you can use smart port telemetry and F port. So there's also a place to hook up an LED strip right here on 9, and a place to hook up a buzzer over here. Now you also have your current sense and your battery voltage that's going through this cable, which will display on your OSD. Now keep in mind, to use these 2 servo outputs right here, you'll have to solder some wires from these pads 5 and 6 to the power board, and that's in the manual as well. I left 5 off by accident and my rudder didn't work, so just keep that in mind. Now there's also a place to hook on a GPS right here on TX4 and RX4, and there's also 5 volts and ground available. I'll get into how to wire up the GPS later in the video. Now I have put the Radix wing kit on my AeroScout plane, and the configuration is like this. I have the flight controller and power board in this location right here, and then I have the GPS right here. Now if you want to see more about how I installed this into the plane, I'll put a link to a video that has the complete install of all the components. Now here is the manual for the Radix Li wing kit, and it has instructions here on how to get the iNav configurator, the firmware releases, and how to install it, so you could look at that. Now I've got some links right here, and we'll get into installing the firmware. Now the first link I have is a link to the page that you were just looking at with the instructions. And then I have the firmware releases, the configurator, and a program called ZADig. Okay, let's start out with the firmware releases. We'll go here, and these are special releases made just for BrainFPV, and right now 2.3 is the newest one that's kind of experimental, but I'm going to go ahead and download this one right here. We'll come down here, and here is the hex right here that we can download. So I'll do that and start that downloading. And let's go ahead and get the configurator. And since we are using 221, we'll just get the configurator for 221, and that is right here. And we want the one for Windows. I've got a 64-bit Windows, so I'll take this one. And we got that one downloading. And finally, we'll get ZADIG. It's kind of strange where you find it. You scroll down through here. It's actually this little link right here. It's easy to miss. And these are the directions on how to use it. So let's click that, and we'll go down here and download that. There it is. Okay, so we got all three things downloading. Okay, now that we've got all three things downloaded, let's go ahead and unzip the configurator. So we'll right-click that, and then go ahead and open a new window. Now we'll just go ahead and drag that folder over into here, so that will unzip it. Now we can close this window and go ahead and open the configurator file and run the configurator, which is right here. Now the Windows Protect will come up. You can just go to More Info and then say Run Anyway. That's Windows 10 for you. And now the iNav configurator comes up. It does say there's a new version because there is. We took the lesser version to match the firmware. Okay, from this point I'm going to show a video clip of how I installed the firmware on a Maytech controller, which is basically the same procedure. So let's take a look at that. If this is the first time you've ever flashed, it won't work because it won't pick up on the proper USB port. So while it's in the USB firmware mode right here, it's a good time to run ZADIG. And you have to go to Options and then List All Devices, pull this down and look for STM32 bootloader. And then you go ahead and you can install a driver. Now I've already installed it, so it's asking me to reinstall. I could hit the button, just go ahead and reinstall. Successful. Alright, so that's done. Now we're just going to continue to leave the board plugged in, and we're going to go back to the iNav configurator while it's still plugged in. We're not going to connect though, we're just going to do the firmware flasher. We'll bring up the firmware flasher, and we want the full chip erase and no boot sequence. That's good. Okay, so now we're going to load the firmware right here, and we're going to have to find it. So we know it's on the desktop, and it was under new folder, and there's the firmware right there. The hex file, open it, and then click flash firmware. And you can see it's erasing right now, and now flashing. Verifying, and it's done. And now you can see the lights are starting to blink, so it's not in the firmware mode anymore, and it's got new firmware. We'll go ahead and disconnect from our USB port. Alright, now we can go ahead and plug it back in. The light should start blinking again, and we should be able to connect. And there it is, and you can see if I move the board that it rocks around on the screen. Okay, now we'll get into the configuration part. iNav has got pretty good at being user-friendly now. You notice right up here it says mixer not configured, use mixer to set it up. So let's go ahead and go to the mixer. And right now we've got a quadcopter there, and we don't want that because this board doesn't even work with quadcopter. So let's go ahead and change this to airplane right here for the platform. Now, this is where we could pick a flying wing if we wanted to and use 3 and 4 servos, but we can come down here and there's a lot of choices. You could have a flying wing with differential thrust. That'd be good for a Kraken, for example. Now I've chosen the standard airplane, and this is the configuration for it, but this is actually wrong for the Radix Li board. What it should be is one motor right here on the front, so this should be 1, and then you would have 2 and 3 for the ailerons, and then you would have 4 for the elevator and 5 for the rudder. Of course, you can always change it down here in the servo configuration if you want to and kind of move things around. Okay, let's load and apply. Says it overwrites. We'll save and reboot. Now, it doesn't reconnect when it reboots. It says something about failed to close serial port. No big deal. It still worked. Just go ahead and hit connect again. Okay, now we've got another message. PWM output is disabled. Motors and servos will not work. Use the configuration tab. So we just go to the configuration tab and enable the motor and servo output. And then save. Connect again. Alright, let's go ahead and go back to configuration. I like to enable don't spin motors when armed. After all, it is a plane. We don't need the motors spinning up on us when we arm it at all, right? We could select our PPM output as well down here. How about this one? We'll just do PPM RX input. Well, let me save that. Reconnecting. Now back to the ports tab. All we need to do is basically make sure the GPS is on. And that's it. Go ahead and save it. Go back to configuration. Now you can see that we could enable a GPS, but I don't have one plugged in right now. If you did want to connect a GPS, you would follow these directions here and connect it to TX and RX4 right here, and then you could pick up the ground and voltage right here on this side of the board. And if you look back at the ports tab, you can see that the GPS is on serial port 4, which corresponds to TX4 and RX4 on the flight controller board. And remember, when you're connecting a GPS, the TX goes to the RX and the RX goes to the TX, so just keep that in mind. Okay, then you would go to your receiver tab, and if you had your receiver hooked up and bound to your transmitter, you could see this working, and you could pick your channel map, which I usually pick this one. And you could also enable RSSI if you're going to use that on whatever channel you want. I use channel 8 a lot because my RSSI comes over a PPM channel. I'm not using analog RSSI, I'm using it over channel 8 from the receiver. Okay, so for the failsafe, I think I'd want return to home for the failsafe right there. That's what I'm going to do. For a plane, that's probably the best thing. We don't want to just land, that wouldn't be good, or drop out of the air. So EZUHF doesn't do failsafe very well. It's hard to set up. For one thing, it doesn't have the no pulses setting. And the other thing, it really can't do throttle failsafe without a workaround where you move the throttle trim all the way down and then set it and then move it all the way back up, which is kind of a nuisance. So what I usually do is hardware failsafe. So I put the switches and sticks in the positions I want, and then I just push the button on the back here. So I'll show you that. Now the receiver has to be on when you do this, so the plane has to be on. So put the modes that you want. For example, I don't want it to disarm, so I'll arm it.
Arming protocol. Confirm GPS before launch.
Then I'll go ahead and put it in the mode I like
angle mode.
Angle mode, which is stabilized. And then I'll go ahead and put it either in return to home or failsafe, which I have set up on a switch.
Auto mode.
And then I'll go ahead and set the throttle to the position I want it to be in. Usually it's all the way down, or you can put it up on cruising speed, like this, so it doesn't have that drop out of the air type thing. Alright, now once you got everything set, just go to the back and push the bind failsafe button. You get 6 beeps. And once you get the 6 beeps, that sets the radio and receiver so that when you lose signal, or perhaps the radio just gets turned off, that the plane will then go into the configuration that you had the switches and sticks in. So that means it'll keep on flying, it'll be armed, it'll be in angle mode, and either failsafe or return to home will be activated. Okay, let's go to the modes tab now. For angle mode, we can set it right there and put it on the channel that we want. Channel 5 is fine for me. Okay, now horizon mode. Let's add that. Let's put horizon mode up here. So you'll have to set up a switch on your radio for channel 5. So when the switch is in the first position, you won't have either of these, and that will basically put you in acro mode, where you don't have any stabilization. And then you flip it up once and you'll get angle mode, which is stabilized mode, And then if you flip it again, you'll get horizon mode, which is stabilized mode with a little bit of acro at the extent. So if you move your sticks towards the outer section, you'll get more of an acro type feel to give you more control, but in towards the middle, it'll be stabilized better. I think that's about all I set there. You could put in a return to home switch if you wanted to. Okay, I think return to home doesn't appear until you have a GPS set up. So I won't put in return to home, but I think when the GPS is enabled, it appears down here at the bottom where you can set it to a switch if you want to. Okay, so now let's take a look at the OSD. It will appear right here. You can go ahead and configure that. Now this board comes with an OSD already on it, and you can select these things to put whatever you want onto the screen. So say you wanted heading. You could turn that on. You can see the heading appeared right there. Or you can turn it off. So those are the things that will appear on the screen. There's some common things that most people use right here. You can just go with that or add whatever you want to do. I also like to choose my settings over here. I like Imperial, so I said Imperial, but you may not want to. I'm going to leave the video format on auto, so it'll pick either NTSC or PAL according to the camera. So just go ahead and save that. So the OSD is very easy to configure as well. Okay, let's go back to configuration. Now, if you have your board turned around backwards, you might want to change the yaw. So I'm just changing the yaw there. I'll go ahead and save that. Okay, let's go ahead and look at the servos tab right here. Just the way the hardware was configured on the plane, the way the servos were set up, it was working in reverse as far as the feedback for the flight controller and on the radio. So rather than change the radio, I just went ahead and just did this and reversed them. So it's handy they have those reverse features right there. Okay, let's go ahead and save that. Now on the motors tab right here, once you get everything hooked up, you can calibrate your motors. You can turn them on here, make sure the props aren't on, turn them on, run the master all the way up, plug in your ESCs and they'll go beep, beep, and then you just pull these down and that does your throttle calibration. Not doing that right now because my motors aren't hooked up, but I just thought I'd mention it. So here I have the controller with the receiver connected, and my radio is bound to the receiver, and I have everything set up on the radio. So you can see when I move the aileron right here, you can see that moving for roll. Then we have pitch right here. You might even hear the plane moving because I have the controller in the plane. This is the yaw for the rudder, throttle. And then we have the switch. So
Stabilize mode.
there's stabilize mode.
Horizon mode.
There's horizon mode that we set up in the modes tab.
Stabilize mode.
And then channel 8 here, that's the RSSI channel, which I have set up here. And I just configured my EZUHF receiver to put the RSSI on channel 8. So it's coming right in through there. Actually, you don't need to set up any channels on your radio to set up the EZUHF RSSI. I just set up channel 8 on the receiver itself for the EZUHF RSSI to work. Well, 12 was returned to home. Right here I have a GPS hooked up too, so that's a bonus. So I have returned to home as well. What I didn't show you was the calibration right here. By the way, you don't have to do the compass calibration because there is no compass for a plane. We're not using that. Just the accelerometer calibration. And you hit calibrate accelerometer 6 times. And you put the board in the upright position. So you click it, put it in the upside down position, click it again, turn it facing to the right. Then keep doing that up, left, down until you get it all calibrated, and when you're done you'll see these values down here. These 3 values will change from, I think it's 4096, I believe it is, to something different. If they just remain on 4096, it means you didn't complete the calibration properly. Okay, here's the nav return to home. That popped in after I enabled the GPS, and I just set it so that when I flip the switch over here, you can see this pointer moves up into that area to enable return to home. Whether it works or not, I don't know. To be tested. I think I made a CLI change And the reason for that was the RSSI. I wanted to set the range for the RSSI to work better because it was only showing 81%. So I went into the CLI right here and I typed in set RSSI underscore max equal 81 and I saved it. So if like your upper range is 81, then you would do set. This gets it to be 100. So RSSI underscore max and then put equal space, and then whatever it is on your OSD. If it says 81% and you want 100, just put 81% and that'll make the max appear to be 100. And there's also a min, like if your min wasn't 0, it was showing 20, you could change this right here to min and then say equals 20 and then it would set that so you got 0 to 100. The cool thing about the min-max settings is you can now handle inverted RSSI signals by making the min high and the max low. In PPM style RSSI, it won't actually show up on the OSD screen unless you make a change, and you can't do it in iNav. You have to actually go in the radio stick menu by holding the cyclic stick down and the throttle stick to the left. Go in and change a certain setting, which is CS or CRSF. Change that to no. I had it enabled and I just disabled it, and then I went and saved the settings. Now another thing I needed to do was get rid of the rails on the side that had speed and altitude, and I couldn't do that in iNav either. So again, I had to go back into the radio stick menus, or the OSD stick menus using the radio, and change two settings in there to disable the two rails. And that was altitude scale and speed scale. Now here's a slide with some additional settings that you can set in the CLI to give you better performance, and there's a description under each one so that you can see what it does. There's also a few other slides that contain all of the settings that I used in iNav in all of the tabs, starting at the top and going down to the bottom, and you can look at them and see if they're helpful, or you can compare them to your settings and see what you have. Okay, so thanks for watching. If you have any questions or comments, just put them under the video. And don't forget that I'm going to have other videos in relation to this, such as the maiden flight with iNav, and also we're going to have some videos on auto trim and auto tune for getting your PIDs just right so you get a great flight. So stay tuned for those, and in that light, don't forget to subscribe and check that bell icon so you'll get notifications when these videos come up. Thanks for watching.